Okay, so P10.8, Forces in Elasticity. So what we're going to look at is we're going to look at a simple experiment where we hang some masses from a clamp stand using a spring. And what we're going to do is, first of all, we're going to measure the spring's original length. And then we're going to add some masses, and that will give us the final length. And the extension is simply the final minus the original. Okay, so how long is it to start with? How long is it after we've added a weight? The extension is the difference between the two. So if we do that, and say if we add 100 grams and 100 grams is 1 Newton, so if we do that 1 Newton at a time, so 1, 2, 3, 4, and we then plot that on a graph, we'll get something that looks a little bit like this. It should go through the origin. If it doesn't go through the origin, then there's an error in your experiment. Zero force should be zero extension, so it should go through the origin. If it doesn't, then there was a slight error on your experiment. You draw your line of best fit, you calculate your gradient. Your gradient is going to be equal to y by x, where y is the extension and x is the force. And you see from the shape of the graph, you can see that it's directly proportional. Because it's a straight line. And in physics, if something is directly proportional, if it's a straight line, remember that tells us that F is proportional to E. So we know that F is proportional to E. What we don't know is how is it proportional. So remember, in physics what we can do is, if we want to, we can say that E is equal to some constant times by E. And this constant we call this the spring constant. Okay, now this is where the maths gets a little bit more complicated. So that's where this F equals KE or F equals KX. Some people use X for extension. I've used E here because we had an XY graph. I prefer E to X for that reason, but people don't like E because that's a mathematical term. Okay, so your gradient was E over F, but you can see that K equals F over E. So if I just rearrange that, I can see that K equals F over E, which means that this is the wrong way up. So if I say that 1 over the gradient equals K. Now, you only need to do that. The reason why I did that was because the standard way of doing a graph is because you put your independent variable on the x-axis, that's the one that you're changing deliberately, and you put your dependent variable on the y-axis, that's the one that you're measuring. So that meant that my gradient was 1 over the spring constant. Because if I put this one on the y-axis and this one on the x-axis, the gradient would be just equal to k. So just be careful which way around you're given these on your axes as to when you're working out k. Okay. So that gives you a spring constant. Now, if you've got a graph like this, with the extension on this axis, and you had one, for example, that was like this, you would say that that one has got a lower spring constant because it's got a steeper gradient, and this one has got a higher spring constant because it's got a less steep gradient. And remember, that's because if you put extension on the y-axis, then it's 1 over the gradient. Now, not all graphs, let's go back a step actually. This bit here is called Hooke's law. And if you get a straight line like this, it's telling you it's behaving proportionally. But you might not always get a straight line like that. Sometimes you might get a graph that looks like this, for example. So it might be straight, and then it curves. Okay, and this bit here, that is known as the limit of proportionality. So it stops behaving in proportion to how much force you apply to it. And basically what you've done is you've bent your spring out of shape. It won't go back to its original shape, it'll go back to an increased length, because you've had too much force for it to cope with. And different materials have different limits, they have different shapes, so they behave different, they're stiffer at different points of their stretch. Rubber and glass are particularly interesting if you want to look those up, but limited proportionality. And whilst it is before it reaches the limited proportionality, you can work out what an extension will be from the force using Hooke's law. Once it's gone past that, you can't do that anymore because it's harder to predict how it's going to behave. So only whilst it's in a straight line and obeying Hooke's law can you do that.